So I'm going to go over an example of Newton-Raphson's method. And we're going to use the equation x squared minus 2 to demonstrate it and solve for x using this method. So the Excel file will be provided to you so you can try this on your own, and also a MATLAB code, which is provided. So we're going to go over the Excel example first. So the first thing we have to do is for both Newton's and quasi-Newton's method, have an initial guess, which for this example will be 5. You could try any number. And we have to plug it into the function to get a value. And for quasi-Newton's method, we have to get a second value, which is with a very small change in the x value. So for this, we're going to do 1e negative 5. And we do that so that we can get the slope of the function by taking the difference of the two over the change in x. And for Newton's method, we take the derivative of the equation to get the slope. And using the function and the slope, we can get the change in x to find a new x, which we'll use to repeat this process, and we'll keep going until we get a solution. And for this, it will be 1.41. And here's the MATLAB code. And I'll break it down such as with the steps of Excel that we talked about. So we'll have an initial guess for both the Newton's and quasi method. The equation to plot out the slope to find the new x and how it replaces it. And we're going to have to keep on repeating this process for this example 10 times. And we display the solution, which is shown. So we're going to go over an homework problem that you guys can try on your own. So we're going to use the equation x cubed minus 4x squared plus 3x equals 0 and solve for x using Newton-Raphson method. And the Excel solution file will be provided if you want to check your answer. So for the solutions, the same method is used as in the example with both the Newton's and quasi method, getting an initial x value as a guess, plug it into the equation, and for a quasi-Newton's, a second point in order to get the slope, and while the Newton's method taking the derivative of the equation. And both results in getting a change in x, which will be used to find a new x value. And this process is repeated until a final solution is obtained. And for the equation provided, there was 3 possible solutions that could have been obtained: 0, 1, and 3. And to get them, it all depends on what initial guess you provided. Because if you did initial guess maybe less than 2, a solution could have been provided of 0 or 1. So we're going to go over the example of how to use Newton's method for multivariable. So we're going to use these 3 equations and solve for x for each one using Raphson's method. And the MATLAB code will be provided and the Excel to go step by step. So on the left side will be the code for the MATLAB in parts, and the right, the methodology for Excel. So the function is provided into both of them, and an initial guess was provided. And Excel gives us a value for each one. The difference or the change in X to obtain the slope, because Newton's method, taking the derivative of the equation is very difficult, so quasi method has to be used. We made each variable dependent on one function. So that is why we did this in the MATLAB code, where the first function will be dependent on the first variable, x1, function 2, x2, and function 3, f3, or x3. And it will provide this array with what is provided. In order to get the Jacobian matrix, basically, we take the new function minus the old one and take the difference of the x to get the slope. And to get the change in the dx, we had to do the inverse of the Jacobian divided by the function. And for MATLAB, we had to use m inverse of the cell above and use the same size and Control Shift Enter to have it accept as an array. And then we had to m multiply the Jacobian, the inverse of Jacobian's matrix and the function. And it gives us the change in x. And a new x value was obtained. For the MATLAB, we had a tolerance of 1e negative 5, and we had to take the norm of it, which is basically the square root of the summation of the dx squares. And for Excel, we had to use Excel solver with the cells and tolerance to get the solution. And this is what the solutions provide, where x1 is 0.5, x2 is 0, and x3 is negative 0.5236. In Excel, we encountered a problem where if the tolerance is too big, another possible solution can be found. For example, x1 is 0.4981, x2 negative 0.2, and x3 negative 0.529. And here's the MATLAB code all together in order for it to work. We're going to go over an example problem for the multivariable. So we're going to have these three functions and solve for each variable. And here's the Excel file if you want to try on your own. So we had to start with an initial guess and plug into the equations for each one. A change in the x, which will be 1e negative 5, and make each variable dependent on one equation. And we get the matrix for each one, for each variable. And this will be the Jacobian matrix we obtained. We had to do m inverse to get the inverse of the Jacobian series in order to solve for it, and multiply with the function. And this is to get the dx change. And with that, a new x value could be found. And we had to use Excel solver with the initial counts and the tolerance cells to get the solution, where x1 was 9.14, x2 12.62, and x3 15.71.